Now this problem illustrates the predicting the direction of equilibrium reaction. So let us read this question first. So we have to find in which direction reaction will proceed. That is, we have to find direction of reaction. To answer this question, we must have a concept of reaction quotient, that is the equilibrium constant expression value at t is equals to 0. So this is basically equilibrium expression value initially, and now k is value of equilibrium expression at equilibrium. Now basically there are three possibilities we can have. One is q is less than k, another is q is greater than k, and the third situation q is equals to k. Now q is basically concentration of product, and this divided by concentration of reactant. Now q always try to becomes k, so q tries to follow k. So if q is less, it will try to increase so that it becomes k. So in first situation, q will try to increase so that it becomes equals to and this is possible only if, so I have to increase q, that is I have to increase the product, that is if I have a reactant and this side we have product, then I have to increase the amount of product, that is reaction will go in the forward direction, that is in the right direction. So in this case reaction will go in forward direction. Now the reverse case, that is q is greater than k. Now once again q will try to follow k, so at equilibrium q will become equals to k, that is we have to decrease the q and then only q becomes equals to q. So we have to decrease and this is possible if we decrease the product and increase the reactant. This means I have to go in this direction. So if I have reactant and product, we have to decrease the q, that is we have to indirectly decrease the product, that is reaction will go in this direction. So in this case reaction will go in the backward direction. So here I can say reaction will go in the backward direction. Now when Q is equals to K, basically this is a situation of equilibrium. So this is basically equilibrium situation. So this is a situation of equilibrium. So now let us remember these conditions. So we have Q is greater than K, Q is greater than K, and Q is equals to K. Now Q is less than K, reaction will go in the forward direction. Q is greater than K, reaction will go in backward direction. And in this case reaction is at equilibrium. Now let us answer this question. So we have equation is H2 plus I2 and this gives you 2HI. Initial concentrations are given. So initially we have 2 into 10 to the power minus 2 mole of HI, and we have been also given 1 into 10 to the power 2 minus 2 mole of hydrogen, and mole of iodine is also given, and that is 3 into 10 to the power minus 2. And the volume of vessel is also given, that is 2 liter. So volume of vessel is 2 liter. So we can calculate concentration. So concentration of hydrogen is 1 into 10 to the power minus 2 divided by 2. So this is concentration. And I2 is 3 into 10 to the power minus 2 divided by 2. And this is 2 into 10 to the power minus 2 divided by 2. So this is the initial values of concentration. So we can calculate Q, that is initial concentration in equilibrium expression. This raised to the power 2 and this divided by 1 into 10 to the power minus 2 divided by 2 into 3 into 10 to the power minus 2 divided by 2. So you see this 4 cancels out and 10 to the power minus 4 also cancels out. So we will have 4 divided by 3. So finally this is 1.33. Now the K value is given in the problem. So it says K is 50.5. So K is 50.5, and now we have calculated Q, that is 1.33. So we have a situation when Q is less than K, that is Q is a smaller. So if Q is a smaller, I have to increase the Q, and this is possible only if I increase the product, that is reaction will go in the forward direction. So in this case a reaction will go in the forward direction. Reaction will proceed in the forward direction. Now let us do this practice exercise. RDI is same. Initially you have been given partial pressure, so you can this time calculate QP, and KP value is also given. So let us try this problem. So you have 2SO3 and this gives you 2SO2 plus O2, all are gases, and partial pressure for each is given. Partial pressure of SO3 is 0.16 atmospheric pressure. Partial pressure of SO2 is 0.41 atmospheric pressure, and O2 is 2.5 atmospheric pressure. So we can basically calculate QP, that is partial pressure of O2 into partial pressure of SO2 raised to the power 2, and this divided by partial pressure of SO3 raised to the power 2. Since this is QP, so we have to put all this concentration at T is equals to 0, so all concentrations are initial concentration. So if we plug these values, PO2 is 2.5 and PSO2, that is 0.41 raised to the power 2, and SO3 is 0.16 raised to the power 2. So if we calculate this value, 2.5 multiplied 0.41 multiplied 0.41, and this divided by 0.16 divided by, let us say, 0.16 into 0.16, so this is 16.41. so we have 16.41. now Kp value is also given in the problem, so Kp is 0.338. So Kp is 0.338, and this is Qp. So you see Qp is this time greater than Kp. So we have to decrease the Qp. We have reactant to product, and finally Qp has to be equal to Kp, and this is possible only if I decrease the Qp. And to decrease the Qp, we have to decrease the concentration of product, that is reaction has to go in the backward direction. So we can say in this case reaction will proceed in backward direction. So lesson for this exercise is we have to basically compare whether Q is greater than K, Q is less than K, or Q is equals to K. If Q is greater than K, this means I have to decrease the Q, and this is possible if reaction goes in the backward direction. So in this case we have a reaction in backward direction. If Q is less than K, I have to increase the Q, that is we have to increase the product. This means reaction has to go in the forward direction. And this is the case when reaction is at equilibrium.